This video is about graphing trig-parallel functions. Now let's graph tangent function. First of all, still, you need to label all angle. Here's 0, pi over 2, pi. Then you have 3 pi over 2. You have 2 pi. Then label the coordinates. Here's 1, 0. And for here's will be 0, 1. -1, 0. I have 0, -1. Yeah, remember that's coordinates always CST. Since we graph tangent function, I need tangent function value for all these 5 quadrantal angles. So you have tangent equals S over C, means sine over cosine. So 0 over 1, that's 0. 1 over 0 means undefined. Here's 0, then undefined. So we need a point that is pi over 4 here. So for pi over 4, we know that's square root of 2 over 2, square root of 2 over 2. Then you have 1. So let's plot the points. 1, you have 0 and 0. That's over here. And pi over 2 will be undefined. That means dotted line, asymptote line. I have pi, then it's 0 again. Then 3 pi over 2 will be dotted line. Okay, so I add pi over 4. Pi over 4 will be middle, that's it's 1 is over here. And for the second quadrant, it will be 3 pi over 4. Tangent will be -1. For third quadrant, you have 5 pi over 4. And that's it's 1 for tangent. So let me plot these points. You will have 3 pi over 4, that's over here. It's a -1, so go to this. And 5 pi over 4 is over here. That's a +1. So we draw the graph like this. Then you have like over here. Then for -pi over 2, that's asymptote line. So for -pi over 4, that will be -1. So I will draw the graph like this. So for the domain, you will write down x not equal to pi over 2. Then that's for every pi, it's repeating because your period is pi. So I add pi times k, or k times pi, and the k will be all integers. For number 1, you can write down like this also. Let me write down here. It will be -pi over 2. Then you have pi over 2. Then it's 3 pi over 2. You have -3 pi over 2. So keep to the dot here. see the x not equal to this. That will be the domain. So that's another expression for domain now. For the range, no ending points at the top and no ending points at the bottom. That means all real numbers here. The graph will be symmetric to the origin 0, 0. So it's an odd function. The tangent function is a periodic function also. So with period it will be pi. Every pi, then it's repeating. The x-intercept will be 0, and you have pi, then you have negative pi. Then it's 2 pi, you have negative 2 pi. So you can write down like this. It will be from 0, then you go to pi, you go to negative pi. Then you have 2 pi, then you go to negative 2 pi. So you keep going. Or you can write down that for x-intercept will be pi times k or k times pi. Then the k is all integers. Either way will be okay. See, this is x equals. For y-intercept, that will be 0, 0. The vertical asymptote line occurs at, pi over 2, negative pi over 2, and 3 pi over 2, negative 3 pi over 2. You can list them up. Or you can do the pi over 2 plus k times pi, because every pi is repeating. Thus, I can write down x equals pi over 2 plus k pi, and k is integers. Yeah, let's graph cotangent function. We still use the unit circle. Here's 0, pi over 2. Then here's pi, 3 pi over 2, and then 2 pi. For the tangent, here's 0, here's undefined, then here's 0, then it's undefined. Reciprocal for cotangent, it will be reciprocal for 0 is undefined. Reciprocal for undefined is 0. Then reciprocal for 0 is undefined. Then you have undefined reciprocal for that, it's 0. So green one will be the cotangent function. And plot these points, you will get 0 undefined. So that's how you draw vertical line. Then pi is undefined. So keep going, is 2 pi is undefined. That negative pi is undefined. So you have pi over 2 means 0. Pi, that's undefined, we already did. 3 pi over 2 is 0. Then you have negative pi over 2 will be 0 also. And we're still using that for pi over 4. Because for pi over 4, then you can get 1 as tangent pi over 4. So reciprocal for this one will be still 1. So you will find like pi over 4 is still 1. That's over here. And for 5 pi over 4, that will be 1 also. And 3 pi over 4, that's a negative 1. So we use these points. You get 3 pi over 4. It's over here. It's negative 1. Go here. Then you have 5 pi over 4. That's a positive 1. Let's go here. Now I connect these points. You will get like this. According to this pattern, you can get a graph over here like this one. Very close to that asymptote line, but never touch. Let's look at the property of a cotangent function. Domain, it will be x not equal to 0, then pi, negative pi, 2 pi, negative 2 pi. For these points, there is a asymptote line. So whenever you see asymptote line, your domain, you always write down x not equal to something. So basically, that's I can write down k pi. Then the key will be integers. Or you can write down that x not equal to. From negative 2 pi, you go to negative pi, you go to 0, then you go to pi, 2 pi, keep going. That's the pattern. For the range, it's no ending points at the top and the bottom. So that's all real numbers. Or you can write down like from negative infinity to positive infinity. And the symmetric of graph will be origin. So for cotangent function will be odd function. And definitely that's periodic function. Pi is the period. The x-intercept will go to pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2. Basically, it's pi over 2. You add that period. It will be pi, then times that k, or k times pi. Then you can write down k is all integers. Yeah, let me write down x equals. So no y-intercept. The vertical asymptote line occurs at 0 pi, 2 pi, and 3 pi, then negative pi, negative 2 pi, negative 3 pi. So basically I can write down x equals k pi. Then the k will be integers. Now let's graph cosecant function. So you will have 1 over sine theta. So first of all, I need to draw the sine function. That's from 0, 0, pi over 2, and then pi, then 3 pi over 2, then it's 2 pi. So I connect like this. For the reciprocal function, find the 0, that's x-intercept. You need to draw asymptote line, because any number divided by 0 will be undefined. That's the first step. Second step, find the 1 or negative 1. because it's still like 1 and a negative 1. Because 1 over 1 is 1, 1 over negative 1 is a negative 1. Then when x equals pi or theta equals pi, cosecant theta will be undefined. That means a really big number. That's why I go this way. That's how you draw it. Then the domain will be x not equal to 0, pi, negative pi, 2 pi, negative 2 pi. So basically it's a integer times pi, k pi. Then the k is all integers. The range will be from positive 1 go to infinity, or you have negative infinity, you go to negative 1. Definitely, cosecant theta will be periodic function. Period is 2 pi because every 2 pi repeating. The vertical asymptote occurs at, just look at the domain. You know, the domain is not equal to k pi because at k pi, then there is an asymptote line. So I can write down x equal to k pi. And k is all integers. And symmetric of the graph will be origin. So it's a odd function. Now let's graph secant function. We know the secant function is equals 1 over cosine x. So we will draw the cosine x first. Your pattern is like this. So I need 5 points, like 1, 2, 3, 4, 5. From origin, you will get, here's 1, here's 2, here's 3, 4, and then here's 5. So we connect these 5 points like this. Okay, first of all, find the x-intercept, then draw the vertical asymptote line. Then find that maximum or minimum points, because when you do the reciprocal for that, still 1. So we draw like this. Okay, so you can look at the domain. It's x not equal to. You have pi over 2, then negative pi over 2. I just use pi over 2 plus k times pi. Then the k is all integers. Or you can write down that x not equal to. Then just list them up like from negative 3 pi over 2, negative pi over 2, then pi over 2, 3 pi over 2, then keep going. For number 2, the range will be from 1 to infinity, or from negative infinity to negative 1. The secant function is periodic with period is 2 pi. So every 2 pi repeating. The vertical asymptote line occurs at, just check the domain part. So you get the x equals pi over 2 plus k pi. Then the k is integers. So for the symmetry of the graph will be reflected across y-axis. So for the secant function, it's an even function.